As you know, this institution, the New York Botanical Garden, is one of the world's great plant research and conservation organizations. And one of our young scientists, I thought I would introduce him to you this morning. He's Dr. Rob Noxie. He's right here in the third row. He's the fourth row. Rob Noxie is in charge of our North American research program. And his biggest project here is to update a very famous flora of the plants of the Northeast called Gleason and Cronquist, which many of you know and probably have used. It was last published in 1991 here, and Rob is updating it and will be putting it up online soon. In 1991, 20% of the spontaneous species living in the northeastern US were non-native. 20% of the species, and that was about 860 species, and that information is all available in that flora, 860 non-native species. Today, Rob estimates, and he's only part way through his work, he estimates that closer to a third of all the spontaneously occurring species in the Northeast are non-native. That would mean that we've moved from about 860 non-natives here to 1,500 in 23 years. So that kind of authoritative documentation is what the New York Botanical Garden specializes in. It's one of the things we've been doing here for a long time and we continue to do. So it's something to think about as we move through this morning's program. So our next speaker is Vanessa Sellers, who looks like she's about to leave the room. Vanessa Sellers is the new coordinator of our Humanities Institute, which is lodged in the great library, the great Lou Esther T. Mertz Library here at the New York Botanical Garden. So please, Vanessa Sellers.
Good morning. I'm the coordinator, indeed, of the new Humanities Institute here in the New York Botanical Garden, which is a division in the Mertz Library, established with support of the Mellon Foundation, and with the mission to bring the arts and sciences together again. I'm very pleased to welcome you all this morning. It is the Humanities Institute's second symposium entitled The Changing Nature of Nature in Cities, a most current topic. This symposium will continue to ask poignant questions about nature and life in our rapidly changing cities. The Humanities Institute's inaugural symposium in June was about greening of the city and the role of women therein. This symposium today will focus on the impact of human activity on the natural environment worldwide and the development of novel ecosystems in our modern cities. We're all very excited to see so many of you gathered here this morning to be part of such important conversations, which are meant to offer, through their discourse, innovative, interdisciplinary approaches to the environmental humanities, as it is called today, and that means studies in the arena of urban planning, landscape and garden design, ecology, environmental ethics, cultural geography, and climate change. In addition to symposia and smaller colloquia, the Humanities Institute offers a fellowship program. More information about that can be found on these green sheets, which were on the registration table and in the vestibule here. And please take one to study that. It is my distinct pleasure now to introduce our moderator for the day, Todd Forrest, the Arthur Ross Vice President for Horticulture and Living Collections here in the New York Botanical Garden. And Todd is familiar to most of you. He is the person who developed the topic for this symposium, and he will hold the reins in hand when it comes to the timing and to the direction the conversation will take during the what may be wild panel discussions afterwards. So please join me in welcoming Todd to the platform.
I've been waiting all my career for a wild panel discussion. Excited to do what I can to help get there. Thank you, Vanessa, and again, thanks to the Mellon Foundation for their support of the Humanities Institute here at the Garden. The changing nature of nature in cities is of great interest to all of my colleagues here at the New York Botanical Garden, an institution that, as Gregory said, that for 125 years has been dedicated to discovering, documenting, and conserving plant biodiversity locally, regionally, and globally. We are advocates for the plant kingdom who have witnessed firsthand an alarming decrease in biodiversity everywhere we study plants, including right here in our 50-acre Thane family forest. As we have seen populations of native plants decline, we have also seen non-native species increase, in some cases exponentially. We are aghast with the vigor with which Phragmites and knotweed and porcelainberry and stiltgrass and mile-a-minute and corktree and countless other invaders have colonized the landscape in and around New York. We have always considered these plants as ugly outsiders, squatting on land that rightfully belongs to species that grew here for millennia before Henry Hudson sailed the half moon across the Atlantic. Over the past few years, a growing number of ecologists, heretics I think as they've been referred to, have asked that we reconsider our deeply held biological xenophobia. After all, the plants we love to hate thrive without care in landscapes physically, chemically, and biologically altered beyond recognition by the relentless forces of urbanization. These exotic species are germinating and growing through cracks in asphalt and on soils contaminated by a truly terrifying melange of heavy metals, hydrocarbons, and industrial chemicals. These pernicious weeds are fixing carbon, reducing erosion, and filtering stormwater. They are the tenacious pioneer species of novel ecosystems that have emerged to fill the vacuum left by the loss of natural ecosystems dredged, cut, filled, or paved into oblivion. This morning, we'll hear from 4 distinguished speakers from very different backgrounds. We have an ecologist, we have a science writer, we have a horticulturist, and we have a landscape architect. And they've been thinking a great deal about novel ecosystems in cities specifically. First, Richard Hobbs, professor of ecology at the University of New South Wales and editor of Western Australia, and editor of seminal work on the subject of novel ecosystems, will teach us how the concept of novel ecosystems emerged and how it applies to cities such as New York. Then Emma Marris, former staff writer for Nature and author of The Rambunctious Garden, will explore how novel ecosystems, reviled by many, could serve as introductions to the beguiling complexity and beauty of wildness for city dwellers with no access to wilderness. After Emma's presentation, we will have a short, and I mean short, break. Discipline here, please, people. After which Dr. Peter del Tredici, assistant professor of landscape architecture at Harvard's Graduate School of Design, former director of living collections at the Arnold Arboretum, author of wild urban plants in the Northeast, and all-around horticultural provocateur, will explain how rural plants can contribute to resiliency in the face of environmental change in urban areas. Finally, landscape architect Kate Orff, founder of SCAPE Landscape Architecture, assistant professor of landscape architecture and urban design, and author of the truly terrifying Petrochemical America, which is for sale out front. It's both a beautiful and haunting book. Will describe how she's addressing altered ecological realities in her forward-thinking design work in New York and beyond. After Kate is finished, I will moderate what I'm sure will be a lively discussion, and please hold your questions until the end of the symposium, until that discussion. So Richard, welcome.
Good morning, everyone, and it's wonderful to be here. Thanks to Todd and everybody at the Botanic Gardens for inviting me here and facilitating getting me over here. It's wonderful to see so many people here today to think about this, what I think is an incredibly important and difficult topic to think about. So I'm going to introduce the whole idea, and I just want to refer to what the flyer for the symposium said it was going to be talking about the concept of novel ecosystems. These are called in this much maligned accidents of unbridled growth. And then we're going to look at how they might reintroduce the wonder of nature into cities. So it's quite a challenging set of topics to pursue. And I thought I had an hour and a half to talk about. Apparently I've only got 25 minutes. So I want to start by saying that you probably shouldn't believe anything I say. This is a quote from a letter that Todd received from Daniel Simberloff, who's a well-known ecologist and invasion biologist, who was very perturbed that they'd assembled a panel of us heretics to come and talk to you about this, and lacking balance in the panel. I would like to think that we will have a balanced discussion, and we'll see how we go. Why do I think this is all important to talk about? Basically, the background is that the world is changing. That even The Economist has recognized this new geological era, which has been now confirmed by the geologists, so the Anthropocene, where humans are driving a large number of the planetary processes that were originally just doing their own thing. What that means is that there's a lot of things changing. It's been called the Great Acceleration by a number of people, including Will Stephan. These are just a bunch of graphs, most of which you probably won't be able to read, but it doesn't matter. These first set of graphs just show you changes in human activity over the past couple of hundred years. And they include things like increasing population, which we know about, changes in GDP. It's got the number of McDonald's restaurants in the world there, and many things like that. The unifying characteristic of all these graphs is that from the 1950s onwards, there's an exponential acceleration in all of those factors. So that's the human activity side. That translates into changes in the Earth system, which are equally astounding. And these include things like atmospheric concentration of carbon dioxide, the greenhouse gases, changes in biodiversity, changes in world fisheries, all sorts of factors that similarly, if you look at all those graphs, the same thing from the 1950s onwards, an exponential increase in the changes. So those slides really made me stop and think quite a while ago, because what that means to me is that we are changing things in the planet faster than we've ever done in human history. Things are changing rapidly, they're all changing all at once, and so we're really in an unprecedented era of human history where things are changing fast and furious. What that means is that we're in a changing world, changing both physically and chemically, changing the climate, and we're also changing the biology of the place. And to me, that means that we really are moving into a new era in terms of what we do and in terms of managing ecosystems and so on. Now, you can look at this in a number of ways, and a lot of people look at it as being a real disaster, that we're going to hell in a handbasket and it's our fault. And then that's, you can certainly see some of that, but the other aspect is that we just have to get used to it, because this is the world that we're living in, and it's not going to change direction anytime fast. Those exponential curves take a long time to slow down. So that's the reality that we're faced with, and I think we just have to figure out, one, how to slow the trends down, but two, also how to deal with the changes as we're moving along. Looking at the way we deal with this in the conservation and land management arena, there's a whole range of different things that people think about doing. And some of them are looking more towards the past, and some of them are looking more towards the future. There's a whole set of approaches and goals that we use based on how far back in history you want to look. So people look at trying to maintain ecological integrity. There's the wilderness concept out there, which is trying to hold things in a kind of pristine state. There's even people who want to go back to before the glaciations and bring back all the animals, the Pleistocene animals that were there. So bringing back elephants and things like that. You can't actually bring them back, but you can import them from Africa. It seems to be the same thing. And we use a number of different methods to do that. Hands off, just let things be, using the historical range of variability and so on. If you do the flip side and start looking into the future, a lot of the things that we're doing are fairly short-term future. Most management plans that people deal with are 5 years maximum, and a lot of the things that we do there are just trying to fix the bad stuff, trying to turn things around as best we can. But then we've got other aspects like ecosystem services, And as we move further into the future, we're thinking about things like resilience, evolutionary potential, sustainability, and so on. So, and that's the kind of horizon that we're looking more at in terms of climate change and so on. So there's a number of different perspectives here, and one is focusing on the past, one's focusing more on the future, and of course, generally we do a mixture of both. The key thing for me is that our level of understanding, both looking back and looking forward, declines dramatically. We're getting a fairly good idea of where we are now. We have a good idea of what's happened in the recent past, but as we go further and further back, our understanding gets sketchier and sketchier. And of course, as we look into the future, we like to think that we're good at predicting what's going to happen, but by and large, we're not very good at all. Our understanding of, especially since all these changes are moving so fast, we really don't have a lot of certainty about what's going to happen. So, what does that mean for where we should be going? Well, I deal a lot with ecological restoration, and I think that's a really good area to be involved with, largely because it's a hopeful enterprise. It's trying to turn around some of the bad stuff and restore systems to either something that was there in the past or to some better configuration in our eyes, which is a great enterprise. And I think throughout the discussions today, we want to not lose that idea of hope, because I think a lot of this stuff can make you feel really quite depressed and in need of a stiff drink. But the problem with the restoration is, as I've just enunciated, we're here now, and we're looking towards the past, which is relatively uncertain, and we're looking at a more uncertain future. And so where to direct restoration in that big morass of things is quite difficult. So to me, talking about restoration is kind of a paradox today, because we're looking towards the past for inspiration, but we can't really go back there. We can only move forward. And how do we do that in an effective way? And of course, we're dealing here mostly with urban systems, and so I'm an ecologist, and I'm used to dealing with the natural systems, the patterns and processes that ecosystems do. But they are heavily linked to the human systems as well, and nowhere more importantly than in cities. So we have the institutions, the jurisdictions, and most importantly, the values and behavior of people that drives a lot of what's going on. And I think a lot of what we're talking about today is in this area of values. Science is supposed to be a value-free zone, but it isn't. Every scientific question has some set of values behind it, and I think we need to bring those values more to the front so that people can enunciate where they're coming from in all this. So just talking about cities, I come to the US quite a lot, but I very rarely come to the Eastern Seaboard. I'm a kind of West Coast guy myself, and I spend a lot of time in the San Francisco Bay Area. But there's a little vignette that I think sort of summarizes the situation we're talking about today, and that's Mount Sutro Forest in San Francisco. So it's a lovely forest. I've spent some time there, and it's just behind the University of California, San Francisco. That's it in the background there. It's an interesting place, and it's part of a big struggle at the moment, because it's you saw the pictures of the forest there. It's an old-growth forest, but it's old-growth eucalypts. They're not native to California, and people alternatively see that as a big problem or as something that they want to maintain. What's happening at the moment is that the forest is seen by the people who manage it as a potential fire hazard, because it's eucalypts, and as everybody knows, eucalypts come from Australia and they burn really easily. So they want to cut some of this forest down and restore it back to what was there before, which would have been a kind of chaparral shrub community. So there's the plans afoot to do this in terms of fire management and immunity. But on the other hand, there's a very vocal and very effective community group who actually love the forest the way it is. They want to keep it the same, and they don't want it messed around with by the University of California or anybody else. They like the forest for its amenity value, and they also say that it functions very nicely, thank you. And the reason that the fire issue is spurious is because it's right in the middle of San Francisco's fog belt. And the trees act as wicks for the fog, and they actually make the whole environment a lot wetter than it would be otherwise. And so the fire risk is minimized in these areas. And they have some quite good scientific evidence to show that this is the case. So this is what the forest looks like in the fog, and if you wander around when it's foggy, you actually get dripped on a heck of a lot. So to me, this really epitomizes the whole question that we're talking about today. These altered systems that in some eyes are a real problem because they're composed of non-native species, and in other eyes they're actually very valued systems both ecologically and socially. So that brings us to this whole question of novel ecosystems and what we're talking about here today. There's a book out the front there, which is horrendously expensive, but well worth it. So I encourage you to all buy it. So don't bother with Emma's book because it's a lot cheaper and probably much easier to read. So, but anyway, in this book we tried to pull together all the information on novel ecosystems, and the basic idea is that you have a range of different degrees of alteration in the ecosystems that we have around the world. Some of them are still pretty much the way they would have been in the past, and in those cases that they're primed for just normal conservation activities, some restoration. But what we're doing throughout the world is changing both the abiotic conditions, the soils, the climate, all that kind of stuff, and changing the biotic composition, both by bringing new species in and by losing some of the native species. And as you move along these axes, we move further and further away from the historical configuration into an area that we call it like a hybrid zone, where there's still native elements there, but there's also quite a lot of non-native or altered elements. As you move further out from that, you get into this zone where things are completely changed. It's completely different environmental conditions and or completely different biological composition. So the opportunities for doing different stuff in these different areas are huge. Traditional restoration and conservation is probably fine in here, but we're suggesting that there's an area as you move further out that it actually gets incredibly difficult to think about traditional restoration or whatever. Either difficult or undesirable because it's very expensive and you're actually probably doing more harm with the treatment than you would be just leaving it on its own. So this is the whole arena of novel ecosystems and the idea that we need to be thinking differently about these altered systems, both in how we value them and in how we deal with them. A couple of examples of the kind of things we're talking about. I'm from Scotland originally, although I live in Australia. Some of you might have picked up the accent. And near where I live are these bings or waste heaps from shale oil extraction. These were done over the last century or so, completely altered soil conditions, rock conditions, like nothing else because they have to process it to get the oil out. For a long time, these were seen as ugly blots in the landscape, and people wanted to get rid of them, flatten them, restore them, and so on. But then from the sort of 70s onwards, people started to actually quite like these things. They were seen as some kind of monument to the industrial past of this area, and they also started looking at them in biological terms. And lo and behold, there's all sorts of species that had really diminished in the other parts of the landscape that were popping up on these heaps. So that the communities there were a real mixture of native and non-native species, but in terms of what they added to the conservation value of the area, they were quite incredibly valuable. So that to me again sums up this kind of conundrum that we have, that these things that started out as being seen as pretty horrible are now seen as a real conservation resource and an amenity resource as well. People use them for recreation. That's another example. This is the Seychelles, and it's a lovely tropical island environment, except for the fact that this is the only native plant in that picture. Every other plant in that photograph is a non-native plant. And so people are really struggling in situations like this. Hawaii is similar, many island situations are the same, about what to do about this. Traditional approaches would be, okay, it's all non-native, let's get rid of it, let's put natives back. But that's almost impossible in situations like this. And so they're having to think really hard about what to do where, what are the species that are real problems that we need to deal with, and what species can we live with. So we have published a variety of papers on this, and this was one that came out in 2009 on novel ecosystems. This was recently criticized by a bunch of people, Carolina Macia and Dan Simberloff, who wrote the letter to Todd. We wrote a response to that, saying they were talking rubbish, and they wrote a response back to us saying we were talking rubbish. So those of you who aren't involved in the scientific enterprise, this is what goes on. This is scientific debate, and it's really pretty stupid. You know, we're just shouting at each other. So I think this is the situation that we're in at the moment, and I think we're trying to sort of move on from it and do something different. Now, those kinds of shouting matches are happening all over the conservation arena at the moment. There's a variety of different problems that people are having, and there's different camps, and it's really quite divisive. And only yesterday in the journal Nature, there was this paper on which I'm a co-author, which is a call for inclusive conservation, saying to the conservation fraternity, look, we're all basically on the same side. Let's get our stuff together and figure out who the real enemies are and move on. So I'd like to think that we can do that too. So just in deference to Dan Simberloff, who suggests that this is a highly biased gathering here, I just want to highlight some of the problems that people have seen with this whole approach to novel ecosystems. One is that the categories themselves aren't helpful. They don't move us very far on. Second, that the concepts don't have any evidence behind them. Third, that we've identified these thresholds where we think beyond which it's hard to restore systems back again, and they argue that it's hard to identify these. It's also wrong to say that we can never reverse things, because anything is reversible with enough time, effort, and money. Which is fair enough, I suppose. The applicability hasn't been demonstrated, and we had a master class here yesterday with a bunch of parks people and other practitioners discussing this very issue. The traditional approaches of restoration, rehabilitation, and reclamation, there are different grades of restoration which have this covered anyway. By embracing novel ecosystems, we're lowering the bar. We're saying it's, don't do the hard stuff, just do the easy stuff. This creates a slippery slope from which there's no return. Once you take on the idea that we've got these systems that we don't need to do anything about, that leads to the possibility that anything goes. And that can produce an excuse for poor policy and practice. So somebody can take this idea and say, look, we've got this system, obviously a novel ecosystem, so let's not bother doing anything about it. And finally, it's been called an ill-founded fad, and if we just close our eyes long enough, it will go away. And in some ways I hope that's true, because this is difficult stuff that we're talking about, and it would be nice if we could just wave a magic wand and make it go away. Anyway, those are all the problems, and I'm happy to discuss all these ad nauseam in the meeting later on. But what keeps me going, despite the criticisms, is that the more people I talk to, the more people actually find this whole thing helpful and often quite liberating. It helps them understand the world they're having to deal with, and actually gives them a framework to work their altered systems in. And also, if the other game in science is the number of times your papers are cited by other people. And so the three papers I've been involved with over the past few years, the scientific literature seems to suggest that most scientists have actually embraced this approach quite readily. Of the total papers who cite this, most are either positive about it or neutral, and there's only a handful who are really negative. So, if you look at it from that perspective, I think, we're doing all right so far. So one of the key things that I talked about is this question of whether the changes are reversible. And that is that the difference between one of these hybrid systems that you can still look at restoring versus one that isn't, and it could be a novel ecosystem. We've been accused of conflating ecology with socioeconomic reasons for being unable to restore something. The argument, and it's put forward by Paddy Woodworth here, who's a journalist and has written a book on restoration. He says it's about social, economic, and ultimately political priorities, and that what we should be focusing on is making sure that we have enough money and resources and so on to make it possible to do all this kind of stuff that we're talking about. And I fully agree with that. I think that we do need to focus on turning things around, on turning society more towards the kind of things that we all care about. And we can throw in world peace at the same time. But in the meantime, we have a society who, by and large, doesn't care. And we've got a long way to go to turn things around. So in terms of thresholds, I think it's a complex area of current concern in ecology. I think thresholds certainly exist. This is an example from Western Australia, where you have a freshwater wetland here. When the saline water table rises, it turns into this. And to me, that's a kind of irreversible threshold. You're never going to get that freshwater wetland back again. Can we identify thresholds? Well, I think it's hard, but we're trying. Is there such a thing as an irreversible change? Well, lots of things are possible, as I said, if you throw enough resources at it. My example here is, though, some of you may remember Black Sabbath, the rock band from the 70s. Turns out that they're making a comeback. They're back in the studio, replete with Ozzy Osbourne. So, to me, things are possible, but are they necessary or desirable, or are they really the best use of resources? Nothing against Black Sabbath, I loved them in their heyday. The other aspect to this, of course, is that we often don't really know what we're doing with our systems. I love flying, and I had the opportunity to fly in a restored tiger moth airplane here a little while ago. Restoration of the tiger moth is a relatively simple matter because people know exactly the specifications of the bits and pieces that are needed, and you can get something which works and looks exactly like the previous thing. If we go back to this Mount Sutro forest, there isn't really a guidebook for how to restore this forest. And unlike the physical components of the plane, there's a bunch of species that are doing their own thing. We think we're in control, but then suddenly the species decides it's going to do something completely different. And so we're constantly trying to keep up with the biology, which is doing things despite us. So in terms of Mount Sutro, I think we can ask the same question that we asked about Mount Sabbath. Can we restore this? Black Sabbath, can we restore this, and should we? Isn't it another viable option to leave it as it is, since people value it and it seems to be functioning perfectly nicely? I think we need to look at the whole gamut of different situations that we're dealing with. This novel ecosystem element is just one aspect of the different... That's time for me to shut up. I've got another hour though, right, Todd? Different elements of the landscape have different things going for them, different services they provide, and all of them can be valuable in some ways. And recognizing the array of things that different parts of the landscape do for us is really important. And this is true in cities as well. And then the approaches that we take to managing these different areas are going to differ as well. Some things we'll want to try and push back to historical conditions as much as we can. Some things we'll want to keep as novel. Some things we'll want to leave alone. Some things we'll want to intervene heavily in. So there's a range of things that we need to think about. It's not a blanket prescription for right across the landscape. And one of the key things I think we've found is that one of the best approaches is not to do the same thing everywhere, because we're really experimenting into an unknown future, and so we want to have as big a range of approaches as we can. Just finally, bringing it back to the local situation, I was fascinated to look into some of the local background here. You're very lucky in the New York area that you have such huge amount of historical information about what the place was like, what the ecosystems were like, and so on. And it's really fascinating seeing just a couple of recent examples of this. I especially liked Eric Sanderson's approach on the Manhattan Project, where he's actually looked at what was there before New York was founded and then what it's like now. And fascinating paired photographs of the previous vegetation and ecosystems and what's there now. What these photographs tell me is, yes, you know a lot about the past, but just how impossible it would be to actually go back to that. When you look at the radical transformation of the environment, we have little patches of it left, some of which are still in very good condition. But by and large, thinking that we can go back to the pre-colonization times ecologically is futile as far as I'm concerned. The other thing that we have to think about is how we're managing this area to deal with the coming trials of the future. Well, they're not future trials, they're current trials like Hurricane Sandy, which I don't need to tell you was a huge event and had big implications for both human society and for the ecology. But what I liked about Eric's book is that he didn't stop at just looking at the past, he also looked into the future. And I think, as I said at the beginning, we have a tendency to look into the future as if it's a kind of bleak place. And there's a lot of fashion about dystopia at the moment, lots of dystopian movies. And this seems to be based here on, so it says here, the human's ability to completely screw everything up. But that's just one vision of the future. And what I liked about Eric's book is that he provided alternative visions based on what we can do ecologically to improve our city environments. And, envisaging much greater use of green roofs, rewilding some of the parts of the city, and just generally doing things differently. And a vision of more concentrated urban areas and giving some things back to some kind of nature, whether that's trying to go for the historical or the new nature. And part of that is in recognition of this radical change that things are happening with climate and storm surges and so on. So, just in conclusion, this is up there for discussion. As I've shown you, it's still controversial. People are arguing about it. Some people really like it. Some people really hate it. I think you need to make your own mind up. Think about whether it makes sense or not. And does it make sense in terms of the local environment here? This is the forest here in the park. Where does that fit into this whole arena? Finally, I like science fiction, and there's this TV show called Threshold, and it's about aliens invading Earth, as always. And the byline there is, "They're here, more are coming, but don't worry, we have a plan." Well, I think novel ecosystems are here, and I think more are coming. And I think maybe we should have a plan for how to deal with it. So, thank you very much.
All right, thank you, Richard. Next is Emma Marris.
All right, thanks so much, and thank you everyone for coming. It's so nice to see everybody. Thanks to Todd and Vanessa and everybody who invited me and put this together. I am going to talk about sort of what is urban nature, what can it do for us, and especially about novel ecosystems in the city. So the first thing I started to think about was about, what's in the city? What have we got? And so my question for you is, what is the place on Earth with the highest floristic diversity? This is a trick question. The typical answer you'll hear is tropical forests, and they have an amazing floristic diversity. But the real answer is a botanical garden, because botanical gardens have even higher diversity. This garden is 250 acres. It's about 1 square kilometer. And in Europe, in 1 square kilometer, you might have about 320 species of plant. South Africa and the Fynbos, maybe you get about 300, 400 species of plant. In the tropical forest in Peru, the Peruvian Amazon, where I was recently, you might have something like 1,400 species of plant in 1 kilometer. But here we have 14,000 species of plant growing in this 1 kilometer. So that's pretty amazing. Now, obviously, it's not, in many respects, it's different than a tropical forest. They are not spontaneous, they're not maybe interacting in some of those ways. But the thing to keep in mind is that they don't know they're in a garden. They're still alive. They're still hanging out, hoping for pollinators. They're still producing fruit. They're still doing what plants do. So they don't not count as nature just because they're in a garden. A lot of the work that I do is to think about how people think about nature. And this is a really, really sort of simplistic graph or a table about how sort of your average Joe on the street thinks about nature. Most people sort of tend to divide up the world into places that are either unchanged or changed, and places that are either unmanaged or managed. So places that are managed and look different than they did 200 years ago, that's things like city parks or Manhattan or gardens or corn grows. And things that are unmanaged and unchanged, things that look exactly the way that they did 200 years ago and are unmanaged, that's nature. That's why it's green. That's why that box is green. That is where nature is. That's wilderness. Nature and wilderness are often kind of conflated by people who are kind of just thinking about this really casually. And then if you've got an area that's unmanaged, that nobody's in there taking care of it, but it looks different than it did 200 years ago, that's a problem. That's an eyesore. That's trash. That's weeds. So this is how I think how a lot of people sort of just kind of casually divide up the Earth. But there's a lot going on right now in sort of historical ecology and paleoecology and regular ecology and restoration ecology and horticulture and landscape architecture and sort of just environmental humanities. A lot of thinking about this, and I think that there's a kind of a new perception that's emerging. And in this perception, instead of saying pristine, we've replaced it with this idea of held to a culturally important baseline. Because the idea that there is anything that's really sort of perfectly untouched by human hands is not really the case. There isn't really any place, especially in North America, that has been untouched by human hands. But there are places that look a lot like they did at really important times in our human history. And then you have places that are changed. And you have places that are managed and unmanaged. So places that are managed and held to this culturally important baseline, that's going to be your Yellowstone, your Yosemite. That's going to maybe be something like the forest that we have here in the garden. A place that is kind of become a space where we think about how ecosystems used to look, but we have to work hard to make those ecosystems look like that. And then we have places that are managed and changed, and that's going to be the big bulk of the planet. That's places that are food production, places that are urban, places that are parks, places that we're taking care, we're kind of managing them, sometimes lighter management, sometimes more heavy management, but they look different than they did 200 years ago. And then you have this category down here, this little box down here, which is where I get kind of a geeky and obsessive, which is the things that are unmanaged and changed. And instead of thinking that as trash and sort of an eyesore, there's this kind of concept emerging of novel ecosystems. But where I get really excited is that I also see this space, I see these areas as actual, that's where our wildernesses are now, right? So if you think about wilderness, it sort of often has sort of two components. One is that it looks like it did a long time ago, and one is that man or humanity is not managing it, that it's wild, that it's self-willed, that it's doing its own thing. And as we kind of do more and more management in big protected areas, in our sort of flagship parks, it is actually these novel ecosystems, these funky little places by the side of the road, these fields that got abandoned and are slowly returning to forest. These are places that are truly wild. And I think that's really something that we need to remember, and something that we need to be excited about. That's something that we need to see as a virtue in these places. So let's talk a little bit about why we switch from this to this. And there's a couple of reasons that we move. And one is that there's not, is that this notion that there is a sort of a pristine landscape that you can return to is just becoming more and more problematic the more we learn about how ecosystems have changed over the last several thousand years. Every place you go has its baseline that they care about. So here it's Henry Hudson, and in Hawaii it's Captain Cook, and in Australia it's Captain Cook, and in a lot of the West it's Lewis and Clark. And I recently gave a talk in Dayton, Ohio, and there it's a guy named Ebenezer Zane who showed up in 1797 after forging a trail from Wheeling, Virginia. And so there it's like, if this plant was here before Ebenezer Zane, it's native. And if it was there after Ebenezer Zane, it's invasive. And so from the outside, this just seems patently absurd. Like, who cares about Ebenezer Zane? But he's just another of these old white guys with ruffs and beards and stuff that every town has the old white guy, and that's the moment that you have to go back to. And that's just, it's very human, right? It's not really an ecological moment. It's saying all the land management that happened before that doesn't count. All the sort of indigenous management that we know happened. So people who lived in North America before all these white guys showed up, they did a lot of burning. They did a lot of hunting, and carefully managed hunting. A lot of times they had sort of different seasons in different areas and no-take zones. They did a lot of planting, and there's a fabulous book called Tending the Wild about how indigenous people managed Californian ecosystems, including just sort of going out and gathering seed and tilling and replanting sort of right out there in the forest and right out there in the grasslands in a way that sort of early Europeans just couldn't really recognize as agriculture because it wasn't in all these nice, neat little rows. So the influence that people have had on this landscape goes back and back and back. And then before all the burning and the hunting and the tilling, you have the Pleistocene extinctions. You have people taking a big role in driving extinct the mastodon and the giant ground sloth and the American lion and all these amazing species. And when those species disappeared from the landscape, there were these ecological ripple effects. A lot of these big animals ate a lot of plants. And when they were suddenly pulled out of the system, grasslands turned to forest, and there were other huge changes like that. So I spent a lot of time trying to look for what was that day? Instead of the guy with the ruff, what is that real day, the day before people? And this is the day before people, because people got here the minute this glacier got pulled back this far. This is about 13,000 years ago, 12,000 years ago. People were already here changing the environment. And this does not seem to me like a legitimate or feasible restoration target, especially in this area. The other reason that we're moving away from that previous view of nature is that we're realizing more and more that ecosystems, even without human intervention, are not static. So this is a sort of a kind of, this is how I was taught to think about how ecosystems function over time, is that they go through these successional changes. This is sort of Frederick Clement's, you start out with your pioneer species, and then you get these shrubby species, and then you get these short-lived trees, and then you get these long-lived trees, and then you get your climax vegetation. And that is it. That is all that is good and right and holy. And once you're there, if you just leave it alone and never screw with it, that'll be it forever and ever. A lot of people kind of learn this in a vague way. As early as elementary school, you kind of get this kind of notion about this. But of course, not everybody has agreed with this. And this is Henry Gleason, who all the way back at the very beginning said, maybe this isn't actually how ecosystems work. And this photo is here from the New York Botanical Garden, because he spent much of his career working right here. He wrote in the 1920s, in 1926, "Are we not justified in coming to the general conclusion, far removed from the prevailing opinion, that an association is not an organism, scarcely even a vegetational unit, but merely a coincidence?" And that's, I think, where ecologists are heading as they do more and more kind of historical work and descriptive work. The species that you see together in a given place seem so right, but often they've only been together for a limited period of time. So I read that 53% of the forest in New York State is maple beech birch. This is the northern hardwoods forest in the Adirondacks. And so that seemed, maple beech birch. It seems like it's a unit, like it's a thing. But if you look at the pollen record through time, maple beech birch are all hanging out together now, but 12,000 years ago, they were barely overlapping. And 20,000 years ago, none of them was a substantial player in North America. These all, as the sort of climate changes, as the glaciers move up and down, as sort of historical chance, I guess, sort of unspools, you'll see all these different tree species moving all over in these crazy directions. And so I kind of, after I pulled up these, I thought, well, God, what was there 20,000 years ago? And it turns out that there was a lot of pine 20,000 years ago, but then as the climate changed, that took off in sort of these weird opposite directions to the south and the northwest. So it isn't just this sort of, orderly procession up and down the continent as the glaciers go back and forth. Every species has its own sort of personal story, its own personal history. And the species that we think of as being kind of inseparable today often have only been recently acquainted. So the third reason that we're kind of reassessing our original division of land into these different categories is the amount of management that it's taking to keep ecosystems looking like they did back at your old white guy baseline. So here's a photo from Yellowstone, and I think that, including myself, when you look at that photo, you think, wow, there's wild nature, red and tooth and claw, and there's the wolves and the bison and the snow, and it's very wild and American and natural. But of course, the wolves were reintroduced in the 90s, and the bison were down to a very, very small number of individuals. And so now they're back, but both of these species are very intensively managed. Every single wolf in Yellowstone is known by name. They're observed every single day. Many of them were callers, and the bison their numbers are managed every year. They go out and cull them, not just for a total population number, but for a total number of males, total number of females, and total number of juveniles. So they structure the population like pruning a bush at the end of every season. And they also vaccinate them against brucellosis. So they also go in and pull out non-native species, and they fish out non-native trout, and they suppress fire, and they garden Yellowstone at a certain approximation. They manage it very carefully. And what they're looking at doing now is, because of blister rust is hitting their white bark pine so hard, they're starting to look into breeding rust-resistant varieties of trees and then planting those out in the forest. And once you start planting specially bred trees, you're really in the gardening zone, I think. So these sort of three things, the fact that nothing's really pristine, the fact that ecosystems change all the time, and the fact that keeping ecosystems looking as they did 200 years ago, 300 years ago requires more and more management. That's what takes us from having this perception to this perception. And often when people make this shift, like when people put all these pieces together, as I did, their first reaction is to feel sad, because you feel like you're losing this box, that this box is going away, and it is. This kind of idea that the unmanaged and the unchanged at the same time in the same place, that goes poof, and that can be really emotionally challenging. But what it also does is that now all these other three areas can be green, because these can all count as nature, because now our criterion for nature is just that there's stuff growing there, right? Just that it's not concrete. And now that opens up our sphere of what counts as nature and our scope for where we can kind of do conservation work to a much broader area. And so I want to talk a little bit about this little box of novel ecosystems. This is one of them in Hawaii. This is when I first saw these forests a few years back with the then graduate student Joseph Mascaro, who was studying them, I was kind of blown away because I had this notion that in non-native species, that invasive species were always monocultures. That you'd always walk out and you'd just see like nothing but Phragmites as far as the eye could see, or just a big heap of kudzu. But what made these systems so interesting is that they're really diverse. They're actually often they're actually more diverse than native Hawaiian ecosystems in many cases. And so this one is one that he called the mango forest. I don't know if there's any mango trees in the shot, but there were mango trees, and then there were native Hawaiian species, and there were species from Asia, and there were species from Australia. And they were like, you know, species from Australia living in the crotches of trees from Brazil and covered with tree ferns from Asia. I mean, they were all interacting in this really sort of ecosystem-y-like way. And as somebody who was from the temperate zone and doesn't know that much about tropical plants, well, I wouldn't even claim to know that much about temperate plants, but if you get out there and you get plopped down into it, it's very hard to just look at that and say, oh yeah, that's trash. Right? Because it looks like a jungle, you know? And Hawaiian ecologists are constantly talking about this, about how these dumb tourists go out there and they look at the jungle and they think it's pretty. Those stupid tourists, because they don't realize that it's all non-native. Well, maybe it actually is pretty. Like there's a possibility that even though it is non-native, there's still some value there. Here's one of these novel ecosystems, sort of an aerial shot of it. So it's by the side of the road. And so if you think about what are our options for a piece of land that's covered in a system like this, I guess the sort of baseline point that I would make is that I'd rather see it green than gray. So I'd rather see all these crazy plants hanging out together than just go and copy what's on the other side of the road and just have a bunch of parking lots and buildings there. You know, at a base level, at least it's open space, it's green space. But it's also doing a lot of other sort of ecosystem functions that we like. These systems, they're creating soil, they're sequestering carbon, they're cycling nutrients, and they're often providing habitat for rare and endangered species. This is my favorite one because this is a new lava flow, right? So the lava flowed out into the ocean in the 60s and then cooled, and then it's starting to be colonized by plants, and these are the first 3 colonists. The ohia from Hawaii, the sword fern from Asia, and the ironwood from Australia. And it's new land, right? So these aren't even invaders. These are the original inhabitants. This is the absolute native flora of this particular lava flow. And so, so what should we do? Should we go in there and pull out all those ferns and pull out all that ironwood because they don't belong? Or should we maybe watch and see what happens? Because I think it would be really fascinating to see what kind of successional processes you see here. One point about novel ecosystems is that they are adapting to all of these global forces, all of these sort of global challenges that we're throwing at nature. Climate change, land use change, species movements. This is their response to it. So at some level, if we think we know better, we know what this ecosystem is supposed to look like, and we're going to go out there with our shovels and our herbicide, we're going to make that happen, there's a little bit of arrogance there. I mean, nature will come up with a solution. It might just look very strange to us, but I don't think that necessarily means that we should rip it out. Joe Mascaro has described himself as a radical Gleasonian because he is so interested in the sort of arbitrary and historical nature of how species come together. So when I found that cool photograph from the New York Botanical Garden, I actually had this t-shirt made, and it's in the mail to him now. So I'll be very excited when he gets it. But to me, as I go through my work and I'm talking to people and following ecologists around, just more and more I see the parallels between human history and ecological history. You know, there's a lot of accidents there. Some archduke gets shot, and pretty soon the whole world is in World War I. Well, some seed gets on a plane, and pretty soon there's ironwood growing in Australia. In Hawaii. So there's a lot of kind of historical coincidence and luck in how the ecosystems that we think of as pristine look. So now I want to talk about novel ecosystems in the city. What time am I supposed to wrap up? 5 more minutes. Okay, so this is Philadelphia, and this is, some of you might know that there's this great elevated, partially elevated and partially subterranean railway that's been abandoned there. It's called, some people call it the Reading Viaduct, and I think there's some other pieces to it, and this is what it looks like from the ground. And this is what it looks like up on top. And this is Dale Hendricks, who's a great gardener, some of you might know, and this is the guy in the yellow shirt is Paul Van Meter, who unfortunately died last year, tragically young, and his vision has been, was to turn this kind of elevated railway into something like the High Line, like Philadelphia's High Line. So we went up there about a year ago, about this time of year, and checked it out, and it was amazing. It was just so beautiful. The spontaneous vegetation up there was just fantastically diverse, fantastically gorgeous, the colors, the textures. I felt really, really privileged to be able to see it in that real wild state. Because, of course, the sort of paradox of something like this is that we love it in a way because it is wild, because it's a little bit of wilderness that has just spontaneously appeared in Philadelphia. But if we want to make it accessible to everybody, they'll probably have to scrape it down and retrofit it for earthquakes and, you know, put up a brand new vegetation. And they might be able to use what we see here as an inspiration, but it will be managed. There was a lot of biodiversity up there. I saw a woodchuck up there and this butterfly. There was just a lot going on, a lot of pollination, a lot of just exuberance. There was all sorts of non-natives up there, but there's also a lot of native species up there. There was a lot of species like this that are really useful, milkweed that are really useful for migrating butterflies. I originally, when I thought I had a longer time, I had like 50 more pictures of this because it's just so gorgeous. And I feel like we're getting to a place culturally where we can look at a spontaneous vegetation on an elevated abandoned railroad, and we actually are having less and less problems seeing that as beautiful and wild. And I think we should capitalize on that kind of aesthetic shift and realize that this is, you know, in some level, we have maybe more wilderness around us here in New York than somebody who lives in the heart of the Yellowstone, because nobody's paying attention. It's doing its own thing. It's really exciting. So here's another one. This another novel ecosystem. This is the backyard of Ilkka Hansky, who's a metapopulation ecologist in Helsinki. And I love this because basically he kind of put his money where his mouth is, and he just stopped mowing his yard. And my husband, if I could, I would do the same thing. But my husband and I are in a protracted discussion about this. But this is what it looks like after, I think, maybe 3 or 4 years of just not mowing. And then he had this cool bet. So he got some of his graduate students to go out and do a biological survey, and he had this big bet in his department about how many species they would find. And how many species do you think they found? 375 species, including 2 endangered species. So to me, you know, I think that, Richard talked about this a little bit, this is an incredibly weird time in our relationship with nature, because we're kind of coming to terms with the fact that these nice little boxes that we made up about what counts as nature and what counts as wilderness, they're breaking down, they're not making as much sense, they're not as useful as categories. And so we're sort of searching for new categories. Novel ecosystems is one attempt to do that. And I think that there are some problems with it. I mean, the kind of obvious problem is that all ecosystems are novel. As I showed you with the pollen data, there's no ecosystem that's been around for more than about 12,000 years without significant change. So you just pull it back, your scale of time just a little bit, and everything's novel. But I do think it's a good sort of transitional concept to help us see value in places that we just until very recently just thought were valueless. Now, and I don't want to minimize the real problems that non-native species can cause, especially where they can cause, you know, competition with threatened or endangered native species, and where they can just be ugly or unwanted, or where they can cause problems with sort of agricultural issues. That's all real. But I do want to say that these places that are really truly unmanaged have a kind of a specialness to them. And although I think that many of them are probably great and ripe for some kind of restoration or some kind of landscape design or some kind of something, I think we should really think hard about leaving some of them just as they are. Because not only will we learn so much from them about how nature itself reacts to these global changes, they will also just continue to instantiate the wildness that has always meant so much to us as North Americans. And they're also just places where we can be wild, and we can feel exuberant and we can love nature in these places in almost a more kind of relaxed way than if we're looking at Yosemite Valley or if we're in Yellowstone in the presence of the great and epic nature that we've just traveled hundreds of miles to see and paid the park fees and just bought this new jacket at REI. You don't have to watch a David Attenborough documentary or join the Sierra Club and go hiking to experience real wild nature. You can do it right there as long as you know how to get over a chain link fence. Thanks so much.
Okay, thank you, Emma. So we are going to take a 20-minute break, which gets us back here at 11 o'clock. So use the restroom, have some cider and some snacks, and we'll see you at 11 o'clock. Moving right along, again, we have a lot to cover and not so much time to cover it. It is my pleasure to introduce our next speaker, Peter Del Tredici. Peter?
Well, it is a pleasure to be here. I think the last time I was here was a climate change symposium. So what I'm going to do today is really talk about when you think about, in the original definition of novel ecosystems, it's very interesting, that cities were not mentioned. Now, the original definition of a novel ecosystem was really talking about non-urban areas, post-agricultural, post-mining, post-forest development. And so this was a big sort of gap in the original sort of literature about novel ecosystems. And I think now, more recently, cities have been included in the concept of the novel ecosystem. But what I'm going to do today is really talk about so let's say that cities are a novel ecosystem. What are the properties of cities that define them as a novel ecosystem? The question of the aesthetics, which I would love to talk about, I'm going to defer to Kate on that one. So, we'll just zip right by this first slide. And I'll leave that question of aesthetics hanging for Kate to deal with. As some of you may know, I published a book in 2010, Wild Urban Plants. The slide is not here to proselytize or to get you to buy it, but to really show you that I selected, based on experience up and down the East Coast, about 220 of the most common urban species, 33% of which are native to North and Central America, 48% Europe, Central Asia, 12% Eastern Asia, 7% to both Eurasia and North America. This was not planned. I just sort of totaled it up after I finished selecting the species. And what's really important is that the vegetation of our cities is as cosmopolitan as its people. And I really like this word cosmopolitan because, people talk about a lot of the vegetation as invasive, as weedy, and so on and so forth, and they clearly its vegetation has an image problem. And, to deal with these kind of image problems, you have to change the language. And cosmopolitan is the word that I like to use in reference to the vegetation that dominates our city. It's not about native or non-native, it's from all over the world. This is the range map from my book, and it includes, from Detroit to Montreal to Boston to Washington, D.C. And you can see when you start talking about urbanization, we're not talking about sidewalk cracks here. We're talking about a major percentage of the surface area of this region. This is based on, definition of cities, which is 500 people per square mile. This map is a little bit out of date, but nevertheless, it gives you the main picture. You may recognize Los Angeles here. You can see the Los Angeles River. And you know, the whole concept that there is a native vegetation in an urban area is a patently absurd idea. You can talk about what used to be there from a historical perspective, but once the city is there, there's nothing that is native to the urban environment. It's a totally human invention, and the concept of a native species in an area like this is just, it's a crazy idea. And what's interesting is the flip side of this is also true. There's no such thing as an invasive species. Okay? So both of those statements are true. In most urban areas, there are neither native nor invasive species. The vegetation that grows there is the vegetation that's best adapted to the conditions that exist. You know, this is the most commonly cited sort of indicator of urban ecosystem, is known as the heat island effect. And you can see on the left hand, the vertical axis, that's the temperature difference between an urban area and a more or less adjacent non-urban area, and that's in degrees centigrade. So 10 degrees centigrade is a little more than 20 degrees Fahrenheit. And on the horizontal axis, I don't know if you can see that, but that's the population. And as the cities get bigger, the difference between the urban and non-urban areas increases. And you know, on a still summer night, that can be as much as 20 degrees Fahrenheit difference in nighttime temperature. This is remarkable. And the main point of this slide, though, is to tell you that, you know, if you're interested in climate change and what is the world going to look like 20 or 30 years from now, all you have to do is go to the city. Because to a certain extent, the cities have already warmed up to the extent that is predicted for much of the non-urbanized areas in the surrounding area. So this is, you know, cities, it's really important that we begin thinking clearly about cities and what cities are going to be telling us about our future. Now, I apologize for this. It's a little confusing slide, but if you know Boston, there's Boston right there. This is the 95 circle that goes around Boston. And this map starts in downtown Boston, here 0 kilometers, and it goes out straight west to the Harvard Forest, 100 kilometers. And these blue dots represent the amount of impervious surface across a transect. These are square kilometers that are adjacent to this Route 2 transect. And you can see that everything inside this 95 ring has at least 30% or more impervious surface. And once you get outside of the 95 ring, with a single exception of the town of Fitchburg right here, everything has less than 25% impervious surface. The reason this is important is this provides another definition of what urban is. And from an ecological, environmental point of view, you can define urbanization as when you have 25% more impervious surface. That's buildings or paved surfaces. And that means that a lot of the land that we consider to be suburban or non-urban, from a vegetation point of view, is actually urban. So it's much more extensive, the amount of urbanization in our area, when you consider to redefine urbanization from the point of view of impervious surface. As Emma pointed out, you know, the history of glaciation goes back a long way in North America, and I analogize urbanization to glaciation. Heavy equipment is quite similar to a glacier, and you know what it leaves in its wake is compacted glacial till. And what you have here is primary succession. It has to start. There is nothing left there. And, you know, that is really what urbanization is all about. Now, this is a sort of interesting map. This is the original landmass for the city of Boston. And you can see the beige here was filled in prior to 1880. There's Back Bay. And then the blue is post 1880. The reason I'm showing you this is, what is the native vegetation to the filled areas, okay? We have no idea where that fill came from. It has very unique characteristics. So over 50% of the area of Boston is totally artificial. So, you know, again, this whole concept that somehow or other cities have a native vegetation is really, you know, I hate to say it, but it's a crazy idea, you know. And this is the Back Bay. This is, of course, right here, and it's famous for its beautiful saucer magnolias in the spring, of course. And you know, it is really it's really a remarkable sort of statement. You know, when you think about it, New York City is much the same way. Southern Manhattan, large parts of Brooklyn, and Queens are built on fill. And of course, these are the areas that are subject to extreme flooding with rising sea level problems and storm surges. When you look at you know, native soils versus fill soils, and I hate to, you know, show you like a slide about soils, but the fact of the matter is that, you know, I'm a horticulturalist, I'm a botanist, I'm an ecologist, and many of you people are, you know, in that same category. Many of you people are gardeners, and you know that everything having to do with plants starts in the soil. If you want to understand the way plants behave, how they're sorting themselves out, you have to start with the soil. So let's just look at the difference between a native soil and a fill soil. Layered structure, distinct zones of biological activity, no natural structure, typically thin and porous, free draining, heavy and compacted, high organic matter content, low organic matter content, low nutrient content, high nutrient content, and high levels of biological activity and nutrient cycling, and low levels of biological activity and often chemically contaminated. So, you know, this is a major difference in these two soil types between, you know, the filled and the original topography. And as I mentioned earlier, one of the really interesting things, so this is the FEMA map for Boston in 2013. This is that original landmass of Boston. You can see that all the areas that are under threat from storm surge are exactly the same areas that were filled. So, you know, it's not rocket science if you want to start thinking about the future in a realistic way. And it really comes from what we've done to the land. And we sort of look at the city and we think it's always been this way, but nothing could be further from the truth. Something as simple as you know, road salt. Nobody wants to compromise public safety for the sake of a few plants. But, you know, people are just unaware of the fact that, you know, just the mere application of road salt, it increases soil compaction, it decreases water availability, interferes with cation exchange, the ability of plants to pick up nutrients, and it elevates soil pH. Just from the get-go. That's this mere act of spreading a little bit of road salt. The plants are totally aware of this, and many of the plants that occur in the urban environment come from areas in nature where they have native high pH soils. So mugwort comes from Europe, and it's native to sort of these high pH agricultural areas, borders of forests and things like that. You know, it's funny, my favorite story about mugwort, Artemisia vulgaris, is the word Chernobyl means Artemisia vulgaris in Ukrainian, all right? So Chernobyl is located in the middle of a vast floodplain that was covered with mugwort. So that's a little fact for you. And of course, the ailanthus that everybody is so familiar with, again, is another salt-tolerant species that has completely dominated all of our interstate highway roadsides. You know, it's really remarkable, but it's just responding to the conditions that have been created by the application of salt plus the compaction associated with, think of all the vibration of all the traffic going by along that highway day in, day out for years, that you lose all your porosity as a result of that vibration. What's really interesting, though, to me, is that the native species are also aware of this. So a common, used to be confined to coastal areas, seaside goldenrod, is now has left the city of Boston, and you can now track it all the way out to Mass Pike to well beyond Sturbridge. And that's within the last 30 years because of the salt applications. And the plant I'm very interested in, Bacchus halamifolia, the ground cell bush, which barely made it to Massachusetts 30 years ago, is now coming straight up I-95 corridor, and you now see it along the edges of all of our interstate highways, mainly as a result of the application of road salt. So it's not just invasives, non-native species that are increasing, it's also our native species are responding to these changes and conditions. And of course, I'd be remiss if I didn't say something about our friend fragmentation. Phragmites. This is, right along the Vince Lombardi exit along the New Jersey Turnpike. And, you could say, this is a horrible invasive species. We have to get rid of it. Or you could say, well, there's, 500 landfills in this area, and this plant is actually helping to clean up the nitrogen and the phosphorus that are leaking from those landfills. And, if you did want to restore this area, that's actually a pretty simple solution. If you just remove the New Jersey Turnpike, you reestablish the tidal flow, and you've got your cattails back. Very straightforward. So Phragmites is an indicator of impeded drainage. It's not the cause of anything. It's a symptom of impeded drainage and brackish water condition. You can get rid of Phragmites by increasing the salinity or by bringing fresh water into that situation. But as long as you have impeded drainage caused by the turnpike, you're going to get Phragmites. This is again, and I really apologize for this slide, but it's really important because, we did a long-term study at the Arnold Arboretum on the native forest soils in urban Boston, comparing them to the rural forests at the Harvard Forest in Petersham, Massachusetts. And this is in response to the hemlock woolly adelgid that was killing hemlock trees. So we did a preemptive cut. We logged the hemlock trees, and then we saw how the soils and the vegetation responded. And we found some remarkable studies as a sort of a preliminary. Before we did the cutting, the soils at the Arnold Arboretum were more compacted, and these are undisturbed urban soils. This is a part of the Arboretum that has been sort of the equivalent of your native forest here. They're more acidic, much lower pH, had a lower carbon to nitrogen ratio, and they had very high levels of available nitrogen and nitrogen cycling, on the order of 10 times higher amounts of nitrogen in urban soils than in the rural soils 100 kilometers west of Boston. That is remarkable. And it really shows in the fact that the black birch that dominated both sites once the trees were cut are now twice the size in Boston that they are in the Harvard forest. It's sort of a conundrum that, a lot of trees actually grow better in urban environments than they do in non-urban environments, mainly because of this quantity of nitrogen that's available in many urban areas. And then you can see here, this is just a graph. This is that 0 kilometers to 100. This is the transect from the Harvard forest. This is total inorganic nitrogen. That's coming from acid precipitation. So this is through fall nitrogen. So this is the Harvard forest, and there's the Arnold Arboretum. And here's the same thing, 100 kilometers to 0. This is the amount of nitrogen in the soil. This is the Harvard forest, and then this is the range of nitrogen found in the Arnold Arboretum on this undisturbed site. So nitrogen is sort of a driver of vegetation change. And if you don't really understand that, and you're trying to sort of restore what used to be here, you have to take into account that the soil conditions have really changed, inalterably, really. So the vegetation that dominates our cities, as I said, nothing is really native to the urban environment, but there are lots of plants that are what I would say pre-adapted to the urban environment. In other words, they come from places in nature that resemble urban habitat. So you have the ailanthus there on the Great Wall of China, and then you have it there on the Great Wall of the Arnold Arboretum. Along the Arbor Way. And, what is a decaying brick building but a limestone cliff? No, absolutely. And the plants, this is how the plants are responding to these conditions. And result in Europe as a result, and this is a result of lots of research. This is the Europeans have been studying urban environments much longer. They're light years ahead of us in the United States, and comparing data from about 30 different cities, they've come to the conclusion that urbanization, and this is really important, favors species that grow well in soils that are relatively fertile, dry, sunny, and alkaline. Okay, that's your profile of your typical urban plant. And you see, so a lot of this vegetation we find is perfectly adapted to the conditions that exist in the urban areas that we have created. Now, it's been mentioned, and I would reiterate that urban areas are, if you just count the number of species and you don't worry about whether they're native or not, are much more biodiverse than surrounding non-urban areas. And this is because of the heterogeneity of the habitats that you find. And for simplicity's sake, I tend to divide urban regions into remnant natural urban landscapes. This would be native woodlands and wildlands persisting from times of early settlement, dominated by a mix of native and invasive species on relatively undisturbed soils. That's a key element there. Low to medium maintenance requirements. Then you have managed or functional urban landscapes, which you can see parks and things like that. Highly modified soils and medium to high maintenance requirements. And then, of course, at the bottom you have ruderal, abandoned urban landscapes. I love that word ruderal. It comes from the Latin meaning broken stone. So a ruderal plant is one that grows on rubble. Post-industrial land, vacant lots, infrastructure edges, dominated by spontaneous vegetation on compacted fill soils, and of course, 0 to low maintenance requirements. And if you define sustainability the way I do, which is ecosystem services provided divided by the amount of resources needed to maintain that, then of course, these ruderal landscapes are highly sustainable. So one question immediately arises: how much land in an urban area, a typical urban area, is dominated by spontaneous vegetation? This turns out to be not an easy number to come up with, but using a variety of surrogates from GIS technology, my students and I came up with a figure using abandoned surface rail lines and abandoned property that for the city of Somerville, adjacent to Cambridge, Massachusetts, roughly 10% of the total surface area was vacant and dominated by spontaneous vegetation. That's more land than there is in parks in the city of Somerville. Now, the story gets really interesting when you start talking about a city like Detroit, where the figure for vacant land is on the order of 40%. So, we're here in New York City, and of course, we forget that, not every place is like New York. In New York, the land has value. Even when it's vacant, it's got value. Just wait a little while, and it's going to be turned into something. What's really, interesting, it's sad, it's really sad, but it's also, is that in places like Detroit, these so-called shrinking cities, the land has lost its value. And the question of what do you do with this land once it's lost its value is a really, a pressing question at a number of different levels. And, it's one that I hope that the landscape architecture profession can really engage, because it's not just a biological, it's a real sociological, cultural, biological issue that we have to deal with. If you've never been to Detroit, as I said, from a socioeconomic point of view, it's a very sad story, but if you're interested in spontaneous vegetation, it's the place to go. They've knocked a lot of the houses down, and orchard grass, a common European species, dominates it. You feel like you're in the countryside. You can hear pheasants calling. It's rather remarkable. The vegetation, the window's broken. There's water on the floor of this old factory, and the willow has sprung up as a little wetland up there, up on the second floor. And speaking of wetlands, this is the loading dock wetland. Clearly the drainage has blocked in here. Notice how the Phragmites is growing right across the line there where the seam of the cement is. And there were red-winged blackbirds singing when I was there. I'm sure there are fish in there. I didn't happen to see any. But, you have this beginning of a whole new ecosystem, wetland ecosystem happening in this abandoned building. It's really a remarkable scene. And this is my big chart. I usually don't apologize for my slides, but again, it's really important. And native forests, you know, if you practice, I've got a little bit truncated there. You know, if they are treated lightly for agriculture or logging purposes and then are abandoned, they can go back to native forest. If native forest is converted to a city and a city to a suburb or that way, or if the agriculture is intense, what you end up down here are these novel ecosystems. And I completely agree with Richard Hobbs. These are irreversible changes. The city is not going to revert to a native forest. It could become a forest, and you're seeing this in Detroit, but it's going to be a novel cosmopolitan forest. And, you know, to me, this is a very, interesting dynamic. And these changes, when you start talking about urbanization, are completely irreversible. And another really, you start going down this road to think about. This is a very important idea. Ecologists love to talk about disturbance as a driver for successional processes, but it's very important to realize that there's a big difference between disturbance and stress. So long-term, large-scale environmental disturbances such as nitrogen deposition from burning fossil fuels, climate change, urbanization, and invasive species are chronic stress factors that permanently alter ecological conditions. Short-term episodic disturbances such as fire, wind, logging, farming, flooding produce dramatic short-term effects that dissipate over time. Native ecosystems are resilient in the face of episodic disturbances, but much less so in the face of chronic stress. Novel ecosystems can tolerate both categories of disturbance. It really is, there's no getting around that. And my last slide here is really the, sort of the dynamics to sum up my basic conclusions about cities as novel urban ecosystems are, and this is important, the interaction of urbanization, climate change, and globalization are chronic stress factors that destabilize native ecosystems and favor the spread of opportunistic species. It's not just non-native, it's opportunistic native species as well. Water, air, and ground pollution impact soil chemistry, which impacts microbial activity, which impacts nutrient cycling, which impacts vegetation patterns. And finally, habitat fragmentation, i.e., sprawl, suburban sprawl, creates sunny edges which are dominated by fast-growing, disturbance-adapted species. So this is it. This is when you start moving into the urban environment, these are the processes that are happening. The issue isn't, do we like them? Do we think it's a good idea? This is biology happening, This is real biology happening, and it's sort of fascinating to watch, and I find it very uplifting, actually, to watch how nature deals with this whole process of urbanization. And, I think that it's not something we need to fear. I think it's something we need to embrace, and how to manage it, this vegetation, to enhance not only its sort of ecological functionality, but also its aesthetic considerations. So I want to thank you very much for your attention.
Okay, thank you, Peter. Our final speaker is Kate Orff, after which we'll set up our discussion. Thanks, Ken.
Hi, okay. So, thanks so much. I'm really pleased to be here. And I'm going to speak more from the point of view of a landscape architect, somebody who's to some degree in the trenches, suffering equally from a love and of my own kind of humanistic childhood, my own person, where I came into the world in '71, which was exactly right at the time where Richard's graph showed this explosion of humanity and hamburgers across the surface of the earth. So I just kind of wanted to tell some stories today about how we work in our office, and also through the lens of these two kind of friends that I've made in such a way, Phragmites and the oyster, because SCAPE, my office, is an office that we are landscape architects. We've been also called sort of seascape architects. I like to work in these kind of in-between landscape spaces between water and land and edges. But the reality is that what we've learned over time is that these, obviously, these shorelines are novel ecosystems. There's been an incredible amount of fill. The water chemistry has changed. Returning to a past condition is not possible. And that these two species, Phragmites and the oyster, I think provide two kind of different clues about how to think about things and just different pathways towards moving forward in a productive way. So at my parents' house, they have a coffee table book called the New York Botanical Garden. And so I was looking through it, and this image came up. And I thought how remarkable it is that the New York Botanical Garden is hosting this conference. This, to me, is almost the kind of idealistic or sort of utopian view of the past of this Felipe von Marris and his dog collecting species in the wild, and how important it is that this conference is happening, because many of us, and this is this kind of cliched image of the city, right? But because we know that the wild is no longer of this ilk, and the city has patches of incredible diversity. So I think it's really important that this conference marks this moment where we're kind of moving beyond these unproductive dialectics and into some new ground. But this is the ground that we operate on in SCAPE. Nobody calls us when there's some beautiful garden that needs to happen, a couple of perennials to be put in. This is our site, one of our many sites. This is a site in Spring Creek in Jamaica Bay and the Outer Harbor. And it's very typical of a kind of a water's edge. You see the tires in the foreground, some very, very toxic looking material in the middle ground, a couple of patches of grasses, and of course the Phragmites in the background. And this is, I think what has become very clear is, although I'm from Annapolis and I am inheriting my lens, which is, this kind of culture of the oyster, this culture of the blue crab, this culture of cities, people, and economies and ecologies that are intricately interwoven. These are the sort of new situations that we find ourselves in. So much of my work is trying to just put eyes on reality, understand, and how to maybe provide infrastructure or a scaffolding, if you will, for species diversity to kind of persist, and but with a kind of realization that we are here, and that the environs in which we find ourselves, not to the soil regime, the water regime, the temperature regime, and the climate regime relative to storm intensities are all shifting. So I think the other realization that I loved Richard's image of the Economist cover about the Anthropocene, because that has very much informed my thoughts, and that is that we are already designing by default, intentional and not. We have designed the landscape that we are inhabiting, and but there are ways to think about somewhat pragmatically moving forward and trying to design this seam between all of these different systems, cultural systems, natural systems, and public life, frankly, and cultivating public life. Landscape architects have often been, I guess, sort of eco-pragmatists through history. This is an image of Frederick Law Olmsted's Franklin Park system and the Fens, which the history here was this was milled basin, it was blocked, it was fetid, there was sewage running into the water system that then was blocked by a mill system. And so Olmsted basically took on basically a public health issue, a landscape aesthetic issue, if you will, and a public space issue and integrated them into this string of necklace of parks. So that is the history, I think, of landscape architecture. We've committed some grievous errors, I think, in the past, but I think there are also tremendous moments when we can start to weave together and not think about culture and nature as being some sort of diametrically opposed thing and chart a path forward. So why Phragmites and oysters? To me, these are the species that I encounter in almost every project, in almost every decision, and I find them to be quite interesting because they are in themselves ecosystem engineers. So they're almost like protagonists in the story of SCAPE's work. Here they are, Phragmites and the oyster, protagonist in this story, which is dealing with an urban landscape in flux, and an urban landscape and a waterscape that is profoundly changed. So I think the idea of the concept of and the situation of Phragmites has been well documented by Peter and many others. But this is where this is this kind of classic view of what is Jamaica Bay with the Phragmites, the kind of landfill in the middle ground, and then the city in the background. And you can see the spread over the United States kind of shifting, not unlike the beech forests and the pine forest that Emma showed throughout the United States, and growing in its physical extents. The reason why I'm also, we have a park project that we're working on in Spring Creek. We also have a project on the Hudson River up in Kingston, and I was, so excited. You go on the first site visit, and boom, 100% Phragmites on the riverfront, and they want to make a kind of a park. So these are the sorts of difficult reality situations that one has to start to weave together or begin to bring together what exists in our people's mind's eye with the kind of realities of maintenance budgets, of plan checks, plan reviews that require native plants, and et cetera. So this is Eric Kiviat's work where he showed that basically the acceleration or the invasion rate is as high as 5 hectares per year. But me, why do I have a thing about Phragmites? Well, first of all, in the Spring Creek project, we learned some really interesting things. This is a zone which is near Howard Beach, and if you know how Superstorm Sandy hit New York, Howard Beach got hit pretty hard. There was overtopping of this artificial berm. But one of the things we learned as we began to try to weave together the need for public access in the form of a bike path, the need for coastal protection planning, which is essentially, if you look at the engineering drawing, it's almost a joke. It's just a giant berm which is 18 feet high, and the need for and the desire for restoration to some degree of the salt marshes and the sort of more shallow embayments. So what we learned in that exercise was that, in fact, Phragmites has a very high friction factor and has high protective value relative to coastal protection. What we also learned from many site visits is that it's incredibly boring to walk through, and it blocks people's access to the water. So these are the kinds of things that I'm thinking about as a landscape architect as we're beginning to engage these sites. It prevents coastal access. So, the other way of beginning to think about these is chemical control, which I wrote this book, Petrochemical America, so you probably have a sense of what I feel about that as a solution. But to some degree, we learned very quickly and very, very much the hard way on another project that there is no statistical relationship between money invested and management success relative to Phragmites. This is a SCAPE project. This was it's a peninsula in Sag Harbor where there was it was really like a terminal standoff between the Ailanthus in the center and then the Phragmites around their edge, and they were in some sort of deadlocked battle in the middle ground. So this kind of looks natural, and that was our goal. We took the project saying, I'm not going to give you privet and grass, just so you know. But what we can do is try to fold in some new species. So This is a design project. We did work on trying to eradicate the Phragmites, and boop, there it is. It always comes back, and so even with an incredible amount of money, which I don't want to say, but there is money to be spent here on intensive land management, on a private small lot, we found that there it is again. And every single kind of moment, although we had I thought, a good strategy of eradication of Phragmites, introduction of beach plum, groundsel, goldenrod, and sumac in different patches and phases and places, it really kind of didn't matter in the end. So I guess this is the sort of way, I close the story with this image, which is that in a way that, in my mind, I kind of see the way that we're going is towards some kind of global gardening or some kind of community-scaled gardening where that these landscapes can still be managed to provide sort of ecosystem benefit, habitat benefit, but public realm access. And that to me is this kind of grand new conception of the word maintenance. So and maintenance and stewardship really. So now onto another story which is about the oyster, and this is another kind of parable, if you will, about working in our local water bodies. So back in 2009, I did a project for the Museum of Modern Art called Oyster Texture, and I became really interested in the oyster as a kind of a unit of change, a unit of life, really, that could provide these multifunctional benefits. It can help to filter excess nitrogen out of the water. It can agglomerate into reefs. It can make the water slower and enable other species like Spartina or that might get washed away by wave action to persist in its lee. And it also just creates this kind of thick 3D mosaic in which other marine life, animals, bird life can persist. And it serves as nature's wave attenuators. And so I began to try to understand the New York Harbor past, present, and future relative to the sort of landscape of the shallows and the sort of how to try to, in a nostalgic way, but sort of use the oyster as a tool to try to project forward into how New Yorkers might live, with the harbor in a new way. So yes, they were a dominant habitat type with over 200 species of organisms, fish, birds, etc. This is an old map that shows, in some extents, the zones here in teal are oyster beds, historic oyster beds. And in our site, which is now, we've developed this project over many years now to an exciting point where we were recently given funding in the form of a $60 million construction grant to fund a protective reef on the South Shore of Staten Island. But I love these images of and these stories about our managed wild, because this is a story of, there were once these historic oyster beds, but in fact this entire shelf off of the coast of Staten Island was leased to oyster farmers and is actually now also an active clamming bed. So there are clam transplants off the coast of Staten Island. Maybe think about that next time you order your clams casino in Tottenville. But I love this image because it is, to me, it's a past, but what I get out of this image is not the concept of some sort of primordial past landscape, but it's an image of people in the landscape working the landscape towards a common purpose. So just to go quickly through the oyster texture concept, it was that we were inspired by the life cycle of the oyster, which went from egg to larvae to spat on shell to a functional wave attenuating reef. And we basically transposed this concept and tried to understand how it meshed within urban life cycles and life cycles of communities and programs. Here's a view of the sort of wave attenuating reef and filtering reef. and how the idea at that time was to make a kind of a new blue park for the next century, the watery century. We began to test these ideas because I thought, even though our work is research driven and that we're building off of Baykeeper data, we're building off Army Corps, we're building off USGS, sensor data and so on, but the question was always like, well, what's going to grow there? Like the Gowanus is a super fun site. So we had this weaving evening to kind of test what would grow, and as almost like a probe in the Gowanus Bay. And then so this is that pilot in water, and it's a kind of funky amalgam of blue mussels and tunicates and so on, but incredible forms of life that emerged. But so as we advanced that project in the form of consulting for Mayor Bloomberg's SIR report, the Coastal Protection Plan, and this kind of tiny pilot project, we also started to look through this project called HUD Rebuild by Design into the entire kind of northeastern seaboard to understand how these bay landscapes that have been so protective are also so threatened due to nitrification and dredging and all these course of many factors. So out of this study, we began to quantify the protective benefit of the shallow water landscapes that are disappearing. I think probably most people in this know the intertidal zone is very endangered in our zone, as is structural habitat. So we developed this project called Living Breakwaters that learned from oyster texture and began to integrate the risk reduction benefits of offshore reefs with onshore dunes, culture in the form of schools and communities onshore in the Harbor School Billion Oysters Project, and ecological regeneration in the form of habitat for finfish and shellfish. So, I guess this is a sort of window into how we work and think. The idea is, how can you kind of hit some triggers to change the cycles, right? How can we start some regenerative cycles in a way that involves people? So now I'm just going to go kind of quickly through these images and give you just the basic gist of the project. This is the zone of the Breakwaters project, which is the south shore of Staten Island. This part, Tottenville, was funded. But this is a map that shows the kind of core protagonists of this project, which is the breakwater, the living breakwater, schools, and the schools walk to shore, and the ecological component. And the idea with this project was not to build a wall. This is very important, that we're not going to build 600 linear miles of walls around the New York shoreline, but what we can do is through a kind of a layered approach, one that looks at the 3D topography of the landscape. We can build a culture of resiliency that incorporates people and programming into the mix. So this section is showing habitat breakwater, floating classroom, wetland restoration, stepped edges, onshore dunes, and yes, concentrated high ground development. So this is essentially the concept of the project. It is replicable. It's essentially a cross-section that connects educators to the shoreline and people to the shoreline, citizens to the shoreline, in the form of these new water hubs that host, that serve as places where you can put your kayak, have a wet lab, et cetera, and that essentially these educators and community members become stewards of the environment in this kind of proactive way that I've been describing. Just a little bit more detail in terms of the breakwaters themselves. This is a cross-section of the breakwater, and we innovate beyond a typical breakwater in the form of having these pockets of micro-complexity called reef streets. You can see here in this diagram how we sort of create zones for finfish and this structural habitat that we learned from U.S. Fish and Wildlife Service that is so missing in our harbor. So it's basically like public space for fish, where the fish can dart out, feed in the street, and then get back into the e-concrete units, which have special holes and pores that can protect them, niches that can protect them from predators. And we design this kind of cross-section that we believe is not only a piece of infrastructure, but it sets into motion a sediment pattern in its wake, and that can host a explosion of diversity relative to the actual shoreline and marine population of Staten Island. So Staten Island was once a big beach town. I mean, I think it still has that sort of island culture there, but the idea is that with these water hubs and with the breakwaters, we can rebuild that public realm, which has been eroded, reduce erosion, reduce wave action, protect development onshore, and then at the same time make a really revitalized and connected landscape in which we build this culture of resiliency through pulling people back to the water, in fact, understanding its properties and its dangers, frankly. So, and finally, I kind of put forward this concept of gardening or stewardship. And this is the other way that I like that this project has become, it's not a singular moment of a project. It's something that's trying to set into motion a new sets of relationships that involve people and involve in a productive way. So we developed this oyster gardening manual with the Harbor School and Billion Oyster Project. I love this kind of. This is the steward of the future. You need this many arms. But the idea is that it's really a philosophy and its approach that is not thinking about landscape architecture as a kind of singular solving a problem at one site, but kind of reframing larger issues of environment and resiliency, and trying to develop kind of productive paths forwards so that everyone can be involved. And I mentioned that I think we're sort of de facto designing our environment by forms of neglect, but I think it's important that we kind of begin to provide these sort of pathways and chart these pathways towards a kind of a more productive relationship. And so finally, just as with the Harbor School student and the 8th graders that we've been working with on the Staten Island shoreline, we also can begin to think about species in a new way. So maybe I need to add goat to my protagonists, but just to end on a kind of a note about management is that there are all sorts of new partnerships that I think we can begin to imagine as we move forward. This one being that the goats find the Phragmites quite tasty. And so I think what's exciting to me is that it's not just a novel ecosystem, it's a kind of a new way of humans and animals and vegetation all sort of living together. So thank you very much.
In my opening comments, I said that this institution has about a 125-year history in documenting, understanding, and we hope ultimately helping to conserve plant biodiversity around the entire world, really everywhere, but originally very, very much so in this part of the world, in this region. We also, more recently, in the past 10 years or so, have been working hard in the 50-acre old-growth Thane family forest, which is the reason why the garden was established on this site in the late 1800s. What we've learned in the Thane family forest is that if we work at it, if we invest the resources, and that seemed to be a common theme in all the presentations, you have to be willing to invest the resources. But if you do, if you spend the time, we actually can have a positive impact on biodiversity, which is, of course, what we value. We are plant people. We are advocates for the plant kingdom. And as many of you might know, but maybe not all of you know, there is a lot of concern about the concept of novel ecosystems. Richard did a great job of summing it up. I think the concern, in short, is that people worry that in some ways, by accepting the idea of a novel ecosystem, the reality of novel ecosystems, we're somehow giving up trying to fight for what we are losing. So with that in mind, my first question will be to Emma. I'll start it off. Where does the value, the moral value of biodiversity, in your mind, fit within this concept of emerging or novel ecosystems?
Well, thanks for that question. I think part of the reason I started my talk with sort of talking about how diverse this garden is because I think we tend to think that a botanical garden is not part of nature. It's more like a museum. It's a different kind of space, right? It's a garden. It's not really nature. And then outside of the botanical garden, we want everything to be sort of the natural areas should all be 100% native. And so we have these kind of really strict categories. And I guess my contention is that breaking down those categories allow us more potential tools to do exactly what you're talking about, which is preserve biodiversity. So if you're only allowed to, preserve biodiversity within the areas that the species was originally native to, then that limits you at a certain level, especially if you've got, the urban heat island effect, you've got climate change, you're trying desperately to grow a species in its historical range, and it's suffering, it's not doing well, you're having a lot of time. Well, you could potentially grow it, further north. In a zone that it's now better adapted to. So I think that breaking down some of these categories that I grew up with and that many of us have sort of just taken for granted for so long does open up more tools for biodiversity. But I also think that we just have to, and somebody else, I think Richard talked about this, we just have to have a diverse strategy, because the challenges that are facing us are so complex and so unprecedented that we don't really know what is going to be the most effective solution. And we also don't know what our descendants are going to value. Like, are our great-grandchildren going to have wanted us to merely save all the species? Are they going to be very concerned that we had left wild places for them? What are the values that they're going to have? So we don't know that either. So what we have to do is we have to try lots of different things in lots of different places. We have to hedge our bets. We have to have a diverse portfolio of strategies. So in some places, it's going to be all about the species protection. Let's manage this land so that this orchid and this fern and this tree and this owl don't go extinct. And then in other places, it might be more about preserving that wildness by not managing, even if that means there'll be some local extinctions. So we have to be diverse in our conceptions of what nature is and also in our strategies about how we reach all those goals.
Okay, thank you. And I have one follow-up question for Richard. So I think what Emma says is exactly right. We have to work together to use the most possible strategies to have the most possible positive outcomes. How do we do that as a society or as a culture if you scientists can't even agree on what the hell we should be doing?
Well, that's a great question, Todd, and I wish I had an answer for it. I think you're hit the nail on the head. I think this is a really interesting and challenging time for both the science and the practice of trying to achieve all these goals that we're interested in. The science is scrambling to catch up with what's going on, and in many cases, I think our connections with practitioners aren't often as good as they should be. And I think the real strength comes when the science and the practice get together and they figure things out jointly. Often the practitioners are way ahead of the science in terms of their thinking, and partially that's because a lot of scientists don't actually get out enough, and whereas the practitioners are dealing with this, the situations daily. So it's interesting and challenging time because we've been through this phase where the sciences of restoration and conservation biology have really ramped up in the past few decades, and it seems to a lot of people like they were just getting a nice set of rules and ways of doing things, when people like me and others have come along and said, no, that's not sufficient anymore, that we need to be thinking about doing other things too to cope with these changes that are going on. If you look at a lot of conservation, it's very place-based and it's very species-based. And you just need to think of the maps that Emma showed to show that species and places aren't as always necessarily connected as we think they are. And what's happening with rapid climate change and land use change and so on is that those disconnects are becoming more apparent. And that's a real conundrum for standard conservation approaches. So there's lots of different ideas around about how to deal with this, and some of them are a lot more contentious than what I've been talking about, things like assisted migration. Should we be actually trying to anticipate what climate change is going to be and move the species there, or do we just let them sort themselves out? So there's all these ideas around. And I think we have to just take an experimental approach to it. Experimental but precautionary as well. Obviously, if we're keen to maintain all the parts as Aldo Leopold required, we need to make sure that we don't do anything really stupid. But at the same time, we don't actually know what the best approach is, so we need to try a variety of things. Some of the rules and regulations that we live under make that difficult. You know, we've got the Endangered Species Act, which in the US, which drives a lot of decision making around things. And you know, some of the action has to be looking carefully at what's happening in the legislation to see whether that's adequate or not. The national parks legislation, for instance, I know a lot of national parks managers actually have to work around the legislation to deal with the situations that they're dealing with. So, you know, these are all tricky issues to work with, but I think we have to all sort of progressively move towards a different way of thinking about these things.
Okay, thanks. Kate, I have a question for you. Wow, $60 million, that's pretty good. That's pretty good for a landscape architect. Congratulations. And I love, you know, what a fantastic idea. I mean, in my mind, as I was listening to you, I was imagining you creating, and quite intentionally, a novel ecosystem. And you intend by design for it to be relatively self-sustaining with a little bit of kind of pushes here and there along the way from its human stewards or gardeners. That's something that we here at the Garden understand actually quite well. I guess my question for you is that what drove that investment, and yours is one of many projects I imagine that were funded through that program, was immediate risk to the human economy and to human lives and to human health and to human well-being. Can you imagine anybody making a $60 million investment in restoring populations of a terrestrial orchid?
No, I also feel like the lens was threat, the lens was crisis, the lens was we need to find a way of thinking about our environment that is not going to shut things down, to shut us off from the water. So I think that the project went through a series of regulatory discussions and so on, which it is actually not legal to do my project right now, in the sense of it is placing fill in the water, right? So right now, and that's, I mean, I didn't have time to expand, but I showed the regional map of the shallow water bodies in the Northeast Seaboard that are endangered due to nitrification and sea level rise and so on. But at the moment, in our regulatory environment, you cannot place fill in the water, even though we know that it is this kind of in between zone, which is so threatened and which is also hosts so much biodiversity, the intertidal zone. So it's a pilot in every sense of the word. It's a pilot that emerged from a feeling of bouncing back, coming back, defining the word, and kind of trying to find the word resilience that catapults over the word sustainability that we used to use 5 years ago, and to try to make this a model for thinking about the future. But no, I think $60 million is a lot of money sometimes. I think it's no money other times, right? I mean, the MTA probably it would cost $60 million to put an elevator in one MTA station, right? So I think the valuing is very relative, and without this cultural component, without the threat, without the sense of risk and return, then it's really not something that is going to scale. And we intend it to scale up in multiple communities, but in and of itself, it was a unique moment and a unique time and a unique funding opportunity.
Yeah, clearly. Okay, my last question is for Peter, because he is a fellow gardener, and your images, as always, of the realities of the urban environment, are a little bit depressing in some ways. But do you think that you say that there's no native vegetation, or the native vegetation is what you're seeing out your window right now, or out the window of the train as you go from Boston to New York. Do you think that the idea put forward by someone like Doug Tallamy, that in this vacuum, in this artificial vacuum, the best and most responsible thing to do is to plant species that sustain the greatest amount of other species, and to actively make that choice, since you're starting with something that's no longer natural? Should we as gardeners garden in a way to benefit the larger ecosystem and the most species?
That's a big question,
It's meant to
and
be.
and I'm sure that if I'll just make the assumption that most of the people in the audience have some form of gardening, and the thing that defines a garden from my perspective is, in a garden you are in charge. It's the illusion of control that keeps us beating our head against a wall, which is one way to define gardening. And you get to decide who lives and who dies. Okay, that is why people garden. Okay, you get to play God. And my thing is, you get to do whatever you want in a garden. Whatever your goal is, that's your business. And if you want all native species, that's absolutely fine. And if you're gardening for wildlife, that's a very admirable goal. The issue is, what you do in your garden, can you scale that up to the landscape scale, to a larger environmental scale? And that's where I think the answer is probably not, because all of a sudden, who's gonna weed all those invasive species? It takes a lot of work to say, I want this, I don't want this. And as you pointed out, it's the ongoing maintenance. It's not a one-shot deal. It's forever. And that, so I completely applaud, and I'm totally in favor of planting native species. But I think the key, and this relates back to what was said earlier, and I've heard this from people practicing landscape restorationists, that the important thing now is to pick your battles. In other words, pick an area that has the capacity to be restored. And that means there's two things. One is it's still got a relatively high percentage of its native biota intact. And the other thing is that the soil has not been radically disturbed. And then you've got a shot at restoration. But the flip side of that is you also have to recognize there are certain landscapes that are beyond any capacity for restoration. It's a waste of time and resources to try and restore something that has been drastically disturbed and is filled with bittersweet. So I think that the sort of the subtlety of saying this is a good, we could invest resources here, we know why we're doing it, there's a rare species in there, we should definitely do that. This area over here, let's just forget about that. That is over. That game is over. And recognizing that, I think, is a really important key to moving forward in the future. It's not some blanket solution that we're going to get rid of all of the Phragmites or something like that.
Okay. Well, I'd like to open the questions up to the audience. Okay. Bill?
There's somebody who just spent all weekend pulling out bittersweet who's just crying.
Hi. Kind of following up on that, I was really interested in seeing Peter mentioning soil microbes and their importance in this process, because mycorrhizae and so many of these things control water uptake rates, nutrient transfer, nutrient uptake, et cetera. So I wonder, what do you think and what do we know about their role when we see a plant invasion, a novel ecosystem developing? Does that always mean that we have a novel microbial ecosystem also below the ground? And is that a driver of the process or responding to the process? Because I think the understanding is really important, particularly if we want to try to do any restoration or management related to that.
Absolutely. No, there's no question about that. And I think I think having the native soil profile intact greatly enhances your chances of having a successful restoration. That's one thing I'm very certain of. The other thing that a lot of restorationists will tell you is that actually poor soil conditions are necessary, like restoring the grasslands in Jamaica Bay. What those plants need is sand. And so the typical sort of horticultural approach, which is giving plants really good soil, lots of nutrients, that just brings on the weeds, And so horticulturalists have to sort of do a 180 on this to realize that, in fact, the native vegetation really likes low nutrient conditions, and that's what keeps the weeds and invasive species in check. So in answer to the broader question of the role of microbes, I think that I used to have this naive idea that somehow these urban plants somehow or other did not have mycorrhizal relationships or something like that. It turns out that with the exception of the Brassicaceae and the Chenopodiaceae, two big plant families, most of the others have mycorrhizae just like every other plant. A plant I've worked with a lot, bittersweet, there's no report in the literature of what its mycorrhizal relationships are. So I dug some seedlings up that the birds had generously deposited in my yard, and we screened them for mycorrhizae, and they're loaded with mycorrhizae. So, I think that the driver is really soil nutrients. I mentioned nitrogen. I think that nitrogen, if you really want to understand what's driving this, why one species and not another, I think the answer probably lies in the nitrogen.
I would guess also the question, we know so little. One of the great paradoxes of these urban novel ecosystems is that they surround all of us, and they probably have more scientists per capita within sight of them than any other type of ecosystem, yet they're probably less well known than the ones that are furthest away.
Right.
Which is, to me, is crazy. I think Emma's idea of the wildness, embracing the wildness, is an interesting one. We certainly should know what we're spending a lot of money to destroy. Oh, is that Eric? Yeah. So I think there's a microphone coming towards you.
Ariel Lugo, who's an ecologist in the Philippines, he used to talk about how he used to spend hours hiking through the crap to get to his study site. And then one day he was like, what if I study the crap?
That's a lot easier.
Eric?
Yeah, so I have one comment and then a question for the panel. And my comment is that historians don't study the Civil War because they want to fight the Civil War again, right? And I think sometimes in these conversations, we have a kind of a simplified idea about what we mean by history and therefore what it means about what we should do. In fact, historians study the Civil War because they want to understand the values that led to the Civil War so we can avoid that in the future. And that leads me to my question for you, which is, I really appreciate the presentations, but there are a lot about the tactics of urban ecosystems, what we should do. But I think a lot of the pushback against novel ecosystems and some of the things you're talking about is actually what the value proposition about them. And so I'd like you to affirmatively say, what do you think our values should be given the changing nature of nature in cities?
Is that to anybody on the panel?
I like all of it.
Well, I'll start. I am maybe, more old school than most people, or many of my colleagues. I think that we have a lot of work to do, and I think there's a lot of hope for native species and natural-ish ecosystems, even in an environment as disturbed as New York City. Here at the garden, the forest, my colleagues in the Parks Department throughout the city, there's a lot of nature in the traditional old-fashioned sense that is worth fighting to protect. A lot of biodiversity, more specifically, really shocking biodiversity that's worth fighting to protect. That said, my experience fighting to protect that biodiversity has told me that there are some battles not worth fighting. So I think the idea of novel ecosystems in the ideal way will help me make the decisions I need to make and prioritize and allocate resources wisely. That's its value to me.
So I think that's a good question. I think that there was a way in which the idea of a sort of an unchanging and unchanged wild nature was handy because then everything that was good was there. And we didn't actually have to be so explicit about what our values were. It was just like, if it was inside that park, it was good. So now that these, kind of the wildness is peeling apart from the sort of historically contiguous, and now we have to just be more explicit, right? So this is a good question to ask ourselves, what do we actually value? And I think it's a long list of things, including biodiversity on the global scale, local diversity, complexity of ecosystems, and wildness as well, we just can't always have all of those things in the same place anymore. So we have to choose which values we're going to try to maximize at any given site. And I think that which ones are going to be personally motivating for any particular person is going to vary quite a bit from person to person. I'm very motivated by species not going extinct. That's one that really, really speaks to me. And that these days, I think that I just tend to care a lot more about things existing than them existing in the right place.
I tend to sort of, it's a really good question. I tend to sort of take a hard line on this whole question, because I think when you try to impose human value judgments on biological systems, that usually doesn't work out very well. It's just like when we try to pass legislation regulating how we interact with biological systems, like Kate was talking about, how do we interact with the coastal environment? Those regulations are no longer really that appropriate for the conditions that exist. But I would say this, that a shocking percentage of the American public does not believe in evolution. It's just mind-boggling to me. And I've put a lot of time thinking about this, and I think the reason that people don't like evolution is that it's not about who's right and who's wrong, who's good and who's bad. It's who is the best adapted and who can reproduce the fastest. There is no moral compass guiding evolution. It's about who wins in the end. And that's Americans, we want the good guys to win. And we want there to be good plants and bad plants. And that is just, a lot of people just have trouble with that. The Phragmites is a great example. In the New Jersey Meadowland, it is cleaning up the Meadowlands. We made a mess of it, and it is cleaning it up. Tell me what the problem is. I don't see a problem. So, that's a sort of I take a hard edge on this whole issue but it's very hard to impose a moral structure on a biological system.
I agree with everything that's been said already, and I think you've hit the nail on the head about the whole problem with this issue and the many other conundrums that we're facing in conservation at the moment. The question is, whose values are you talking about? I have a set of values, but everybody else in this room is going to have a set of values, and they may be convergent or they may be completely different. I'm always amazed when I talk to different people about how differently they see the world from me, which means I could be completely weird, but I don't know. But I'm certain that people in this room have a very different perspective on many things from the millions of other people in New York who aren't in this room. There's a whole layer of societal complexity that we often don't factor into discussions like this, and I think we need to be better at that. But that provides us with a real minefield to negotiate, because there's all these conflicting values, even within the people who know about stuff like this in great detail. And the classic is the native, non-native thing. We are programmed to like natives and dislike non-natives, but maybe that's no longer appropriate. There's non-natives that are only non-native by an accident of history or by a small accident of geography. They're everywhere now. They're doing good stuff in many cases. Perhaps some of the re-evaluation of our own perspectives on many things needs to happen, or we at least need the discussion. So I think scientists aren't generally, as I said in my talk, good at bringing values into what they're thinking about. But everything we do, all the questions we ask, have a value hidden in them somewhere. And one key step to moving forward, I think, is bringing those values up to the surface so that at least we can be leveling the playing field a bit and reaching some common ground on what we're talking about.
I guess I'll just go down the road. Yeah. I think it's a great question, and I guess I could answer it in the sense of that in my own mindset, I feel like I have this sort of empathetic imagination, right? Like I try to imagine the world through many people's different eyes, and also through the eyes of, I suppose, species, right? So I kind of set up my talk as being like the bad guy and the good guy, Phragmites and the oyster, but the fact is that I'm just frankly trying to figure out, what has coastal protective value, what works, what could, be stewarded over time, how could these, how does it relate to public space and people's kind of, interaction with the environment. So, I mean, from a moral perspective, though, I think this, in my big sort of wish, and this is sort of how I ended the talk, which was this, we have made this world through a series of, decisions that have unintended consequences, the burning of carbon dioxide, all, the sort of nitrification of the water and so on. I guess my goal would be that we can somehow reorient ourselves, and exactly as we're saying here in this panel, to be able to understand and make choices about what's important, battles to fight, and to try to begin to recalibrate and because I think I think the sixth extinction is a moral crisis. I do think it is, and I do, find that when I read, books to my two kids at night, I'm like, oh, here's, Ronnie the rhino, and then you actually know the plight of species around the world in our backyards and in places around the world, that it's very difficult to not have that imaginative leap and not want to intervene in some way. And so I think that we have had 100 years in your graphs, and we have to kind of think about what that next 100 years is. And so I suppose that's a sort of convoluted answer to what my values are, but that's what I'm trying to do, change the graph.
Groovy. Back in the back row, up top. Yes, there's a microphone headed your way. We have time for probably 3 more questions.
I'm talking to the discussion of categories of novel ecology, which was spoken about earlier. I recently saw a TED conference about Chile and about this architect, I believe his name was Alvarez, who was creating new kinds of ecological systems in Chile on the waterfront. He was creating perimeter housing. He was creating, because it was a very crowded area, he was creating half housing for tenants, where they could build their own half of their house. But he was creating, in between those two areas, he was creating a forest. Now, can we create our own biodiversity from the beginning? That's what I want to know.
I'll give that one to Peter. Practical.